Good morning everyone. Okay, so today big chunk of biology knowledge, the light dependent and light independent stages of photosynthesis. So we're going to spend quite a bit of time on this. We're going to understand that photosynthesis has two main stages. Just to give you an idea of the spirit you need to be in, I thought this video was adequate. I don't know if you're familiar with the film Mulan, so I'm just going to let you watch a few seconds just to give you the idea of the energy we're going to put in this part. Okay, obviously we're not going to defeat the Huns, but we're going to master the knowledge behind photosynthesis. Okay, ready? Here we go. So the first thing we're going to look at is a historical experiment by Ruben and Kamen experiment in 1940. So let's start with the analysis of this experiment. So first recap, you need to know what is the difference between oxygen isotopes. So isotopes are atoms which have the same number of protons and electrons, however the number of neutrons change. So we've got 10 neutrons here and 8 here, which means if we consider the weight of the nucleus, we're going to have 8 plus 8, 16, that's where we have 16 here, and 8 plus 10 here, it's going to be 18. So 18 isotope is slightly heavier and has different characteristics, and therefore scientists can differ both isotopes and they can follow different molecules. Okay, so let's enlarge this. First experiment, we have a plant which is in a sealed atmosphere, and in this atmosphere there are two things. We've got CO2, so normal CO2. When I say normal, it's the most common isotope. However, the water which is added in the medium, this water has oxygen 18. So this is the less common isotope. So this has been added in this experiment. Okay, so obviously the plant is going to be exposed to light. So let's do a little sun. So light beams coming in. Okay, so photosynthesis is going to occur normally. So the plant is going to take in carbon dioxide and water, and it's going to produce glucose and dioxygen. And what Ruben and Kamen noticed is that the oxygen which is being produced has the 18 isotope. So in their experiment they noticed that the oxygen which was produced had the 18 oxygen isotope, which was not the case for the glucose. Okay, so first thing, when you put water which has the isotope 18 oxygen in it, therefore we can see that the O2 which is produced is made up of this 18 oxygen isotope. Okay, so that was the first experiment. Let's move to the second one. So the second one is similar, only this time the molecule which has the 18 isotope is carbon dioxide. So in the atmosphere we still have CO2, but this time the CO2 is added and it has the 18 oxygen isotope. The water in the medium is with the normal isotope. So when I say normal, it's the most common isotope, the one you would have in a normal atmosphere on Earth. So again, I'm not going to redraw the sun, but there are still light beams coming in, so when there is light, photosynthesis is going to occur. And this time what they noticed is that when the 18 isotope oxygen is in the carbon dioxide, well, the oxygen which is produced doesn't have the 18 isotope. However, the molecules which have the 18 isotope, you have them here, glucose and heavy water. Okay, so you might wonder, why on earth is this interesting? Seems a bit weird. Okay, we know where oxygen ends up. Well, we'll see that this is crucial to understand the next point. We'll see in the next part. So what we can conclude from this with both experiments is that the oxygen which is produced, the oxygen atoms, they come from water. They don't come from carbon dioxide, they come from water. So that's the first conclusion. So in the analysis part, you can write the following. So obviously you can pause the video whenever you want. So the oxygen atoms of the dioxygen gas which is produced during photosynthesis comes from water molecules and not from carbon dioxide molecules. So this is a key point. You can red star this, as well as the understanding of Ruben and Kamen's experiments. So here we are, we know that the oxygen which is produced, the atoms, they come from water. Okay, so we're still in the analysis part. We are now going to explain this using concepts from chemistry. So we're going to talk about oxidation and reduction. Here we go. Oxidation of water. So what we've learned from Ruben and Kamen's experiment is that the atoms of oxygen in the oxygen gas come from water. So we're going to start off by writing down our two molecules. So we've got water. Okay, and we know that this water in a way is going to be transformed into oxygen, dioxygen gas. Okay, so you're probably thinking, wait a minute, there are things missing, and you're absolutely right. For example, we have hydrogens on the left side and they're not on the right side of our equation. So we need to find a way to add these. So I don't know if you know this, but an oxidation in chemistry is a loss of electrons. That means the water molecule is in a way going to lose electrons, and if it loses electrons, the hydrogen atoms are going to become protons. So this is how we can balance the equation. So I'm going to add H plus, so protons. So this is the plus for protons, and this is just the plus. Well, I'm going to do a different color. So this is the pluses for the equation. Okay, and so if we've got protons, we're also going to have electrons. So an E with a minus. That's the symbol for electrons. I'm just going to erase something because I'm not going to have room to place numbers. So I'm just going to move the plus forward. There we go. Okay, so to balance this equation, we're going to add a 2 here. So we're going to have, as a reminder, the 2 means we're multiplying the whole block. So we're going to have 4 hydrogens. That means we're going to have 4 protons here. And so we have 2 oxygens. That's okay, we've got 2 oxygens here. But we need to balance. If we've got 4 protons, we need 4 electrons to keep the equation neutral. So here we are. The oxidation of water is 2H2O, and that's going to be transformed into dioxygen, 4 hydrogens, well, 4 hydrogen protons and 4 electrons. This is the oxidation of water. Okay, so I'll let you write this in the analysis part. So as I said, oxidation is when a molecule loses electrons. So this is the case, water loses 4 electrons, well, 2 electrons. Okay, so let's move on to the next part. We're now going to talk about the reduction of carbon dioxide. So again, with the Ruben and Kamen experiments, we know that the oxygen from carbon dioxide ends up in both glucose and water. So this is what we're going to write. So we're not going to use the full molecule of glucose. We're going to use a smaller version, if I may say so. So let's start with CO2, and that's going to become, so a smaller version of glucose would be CH2O, so that's one block. So I'm just going to add brackets to show it's one block. So if you multiply this by 6, that would be a molecule of glucose, C6H12O6, and you know that is glucose. Okay, plus water, H2O. So again, we know this from the Ruben and Kamen experiment. We know that the oxygen in the carbon dioxide ends up in the glucose and water. So again, you might say, wait a minute, there are things missing, and you would be absolutely right to say so. Again, we're going to be missing protons and electrons. So let's add them. So we've got 2 hydrogens here plus 2 hydrogens, that is 4 in modern maths. So 4 hydrogens, so hydrogens, protons. I'm going to add the plus symbol. Okay, and if we want to balance this in terms of charges, we also need 4 electrons. 4 electrons. So here we are. We're happy now because the equation is balanced. CO2 plus 4 H pluses plus 4 electrons is going to give 1 CH2O plus H2O. So here we are. This is the reduction of carbon dioxide. So you remember that earlier on we said that oxidation is a loss of electrons. Reduction is the opposite. The molecule is going to gain electrons. So CO2 here is going to gain these electrons. Okay, so again, this is still in your analysis part, and we're now going to move to the conclusion. Okay, so let's do the first recap. We've got our 2 small equations. We've got the oxidation of water and the reduction of carbon. What you need to understand is that photosynthesis can be summed up with these two reactions. What is photosynthesis? It's two things. It's the oxidation of water and it's the reduction of carbon dioxide. So this is something you can write, first line of your conclusion. Photosynthesis is two things. It's the oxidation of water and it's the reduction of carbon dioxide. You can even say that photosynthesis is, so these two things, oxidation of water coupled with the reduction of carbon dioxide. This is it. This is what photosynthesis is all about. It's a oxidation of water and the reduction of carbon dioxide. But unfortunately, we'll see that to do this, plants need to do many things and have lots of mechanisms just to enable these two simple reactions. But that will be in the next part. Okay, so if we add the two equations, so if we add the reactants together, so 2H2O plus CO2 plus 4H pluses plus 4 electrons will transform into CH2O, H2O, O2 plus 4 protons plus 4 electrons. So we've added all the reactants and we've added all the products. So we can simplify this just like in maths. If we've got the same amount on each side, we can take them out of the equation and we're left with the following equation. Obviously it's balanced, but what I'm going to ask you to do is try and balance this equation so that instead of having CH2O that we have here, you need to end up with C6H12O6, so one molecule of glucose. So I will let you pause the video and balance the equation in order to have in the equation, instead of having CH2O, having C6H12O6. So you can pause the video and have a think how to balance this equation. Okay, so let's move on. So at the end of the day, here we are. Since S2, you know the simplified equation of photosynthesis. So red star for that, you need to know this. Oh, I forgot to say, you also need to red star the oxidation of water and the reduction of carbon dioxide. Those are also red star things. But you now know that the overall equation of photosynthesis is a little bit more complex. So you've got 6 CO2, 12 H2O, C6H12O6 glucose, 6 O2, 6 H2O. And the reason why we know that this is the overall equation is thanks to Ruben and Kamen's experiments. So you can see that to go from the overall equation, which you need to know, and this is why I've just red starred it, and what people have done to go to this more simplified version, they've simply crossed out 6H2O here and replaced the 12 by 6. So here we are. So let's recap a few things. You need to know and understand these experiments of Ruben and Kamen. You need to know the overall equation of photosynthesis, and you must be able to explain the oxidation of water and the reduction of carbon dioxide using the using protons and electrons as we did. Okay, so hopefully we did it gradually. As I said, we're building brick by brick. So it is getting tougher. So be strong, and we'll get through it. Okay, goodbye. So as usual,